Have you ever really stopped to think about what it takes to just nod your head or, break into a full sprint? The engineering behind it is pretty wild. It's this incredible masterpiece of coordination. And today, we're going to break down that exact blueprint for action.
Yeah, how does that happen? How does a simple thought like, I'm going to wave hello, turn into an actual physical wave? That journey from a little spark in your brain to a real-world action, well, it's a fascinating story. And together, we're going to piece it all together.
All right, so here's our game plan. We're going to start with the foundation, the body's framework itself. Then we'll look at the engines that make it go, the crucial connections that link everything up, how it all comes together in this, well, a symphony of movement. And finally, and this is a big one, how we can keep this incredible machine running smoothly for the long haul.
Okay, let's dive right into section 1, the body's framework. I mean, it makes sense, right? Before we can even talk about moving, we've got to understand the structure that's being moved. Think of it as the silent but absolutely essential scaffold of your entire body.
So your skeleton, right? It's easy to think it's just there to hold you up, to stop you from being a puddle on the floor. But it does so much more. One of its most critical jobs, really, is protection. It's basically a living, breathing suit of armor for all your most important bits. Your skull? That's a custom-fit helmet for your brain. And your rib cage is this incredible shield protecting your heart and lungs from, the outside world.
And our skeleton isn't just one big, solid thing. It's actually designed in 2 main parts, which is super smart. First, you've got the axial skeleton. That's your core. Think skull, spine, ribs. Its main job is protection. It's the stable center. Then you've got the appendicular skeleton. These are your moving parts, your arms, your legs, all the things that let you interact with the world. So one is the anchor, and the other gives you the reach. Pretty cool, huh?
All right, so we have our framework, but a frame, a scaffold, can't go anywhere by itself, right? It's like a car chassis with no engine. And that brings us perfectly to section 2, the engines of motion. To bring that skeleton to life, you need power, and that's exactly where our muscles come in.
And get this, it's not just one type of engine. Your body actually has 3 different specialized types of muscle, each one built for a different job. Some are for those big, powerful actions you decide to make, like jumping. But others, they're working tirelessly, silently, in the background, doing things that keep you alive, and you don't even have to think about it.
Let's break this down. First up, you've got skeletal muscles. These are the ones you're in charge of. Think flexing your bicep. They look kind of striped under a microscope, which is why they're called striated. Then there's smooth muscle. This is the involuntary stuff, the automatic pilot for things like your stomach and blood vessels. And finally, you have cardiac muscle. This one's special. It's only found in your heart, and it's kind of a hybrid. It's striated like a skeletal muscle, but it works automatically, thankfully.
Okay, so we've got a frame and we've got engines. The big question is, how do they actually connect to each other? Well, that brings us to section 3, the critical connections. And honestly, these are the real unsung heroes of the entire system.
First up, we have tendons. The easiest way to think of these is like super strong, flexible cables. They're what connect your muscles to your bones. So when a muscle contracts and generates all that force, the tendon is what transmits that pulling force to the bone, making it move. Simple as that. Muscle to bone. No tendon, no go. Now don't get these confused with tendons. While tendons connect muscle to bone, ligaments connect bone to other bones. Think of them like incredibly tough straps, almost like biological duct tape that hold your joints together. They're all about stability, making sure your elbow bends like an elbow and not, well, in some other weird direction. And our third hero is cartilage. This stuff is amazing. It's this smooth, slippery, resilient tissue that covers the ends of your bones, right where they meet in a joint. It acts like a perfect cushion, a natural lubricant that reduces friction. It's the reason your joints can glide so smoothly. Without it, every movement would be a painful, grinding mess. So let's just be clear. Without these 3 critical connections, the whole system just fails. Tendons, ligaments, cartilage. You could have the strongest muscles in the world, but they'd just be revving their engines with no way to translate that power into action. The frame would never move. It's that simple. All right. We've got the frame, we've got the engines, and we've got all the critical connections. Now for the fun part. It's time to put it all together. In section 4, a symphony of movement. Let's trace that path all the way from a simple thought to an actual action. This all happens in the blink of an eye, but there's a very clear chain of command. Step 1, your brain sends an electrical signal zipping down your nerves. Step 2, that signal hits its target muscle and tells it to contract, to shorten up. Step 3, as the muscle shortens, it pulls on the attached tendon. And finally, step 4, that tendon pulls on the bone and boom, you get movement at the joint. It's a perfect 4-step cascade every single time. Okay, here's a really key concept, a fundamental rule of how our bodies work. Muscles can only pull. They have absolutely no ability to push. So what does that mean? It means they have to work in pairs to get anything done. Think about your arm. Your bicep pulls to bend your elbow, but to straighten it back out, your bicep can't push it. So its partner, the tricep on the back, has to pull. Every single movement you make is this little dance, this partnership. And this whole idea brings us back to control, right? On one hand, you have voluntary actions. These are the things you decide to do: walking, typing, picking something up, all powered by those skeletal muscles we talked about. But on the other hand, you've got the involuntary actions. This is the stuff that just happens automatically. You don't have to remind your heart to beat or your stomach to digest your lunch. That's all handled by your smooth and cardiac muscles. It's an absolutely amazing division of labor. Okay, so we've taken the whole machine apart, looked at all the pieces and how they fit together. That brings us to our final and maybe most important section, keeping the machine running. Because now that we know how this incredible system works, well, how do we take care of it for the long run? Look, keeping this system in top shape isn't a passive thing. You have to be involved. Things like weight-bearing exercise, it doesn't just make your muscles stronger. It actually sends a signal to your bones telling them, hey, stay strong, stay dense. And diet is huge too. Calcium is like the bricks for your bones, but you need vitamin D to act as the builder, to actually absorb that calcium. And listen, as we get older, this stuff becomes even more crucial because we have to actively work to counteract the body's natural tendency to lose a bit of that muscle and bone density. So when you boil it all down, this incredible system of bones, muscles, and all those connections, it's more than just biology class stuff. It is the very machine that allows you to experience your life, to interact with the world, to hug someone, to run, to create. So the final question really isn't just some trivia. Now that you know how it all works, what are you going to do to take care of your incredible machine?
Want to test your knowledge? I've got something exciting for you. Download the worksheets for this topic. They're designed to help you see how much you've learned. It's a great way to check your understanding. So, what are you waiting for? Get them now and start testing yourself. The link is in the description. Go check it out.